Welcome to NASA Cloud Resources for virtual and in-person learning. Just to give you a little orientation to how this is organized today, I do have a Padlet. You can see the URL for the Padlet here on the screen as well as a QR code. In that Padlet, many of the resources that I'm referring to are there. You will also be able to see some links for some of the other things. Some of the resources are repeated. They're in more than one column. So if it's specific to one of the columns, I put it there, but then I also have the column on the far right that has all the resources. I also have an area there where you can put questions on the Padlet, and it also has my email, Angela Rizzi at nasa.gov, if you would like to email me any questions. So I just wanted to get that out of the way before we get started. I do not anticipate that this will take the entire 45 minutes, but I do have two places in the presentation where I'm asking you to pause the video, go and explore the resources, and then make some comments on the Padlet. So I hope you enjoy the presentation today, and I'm going to get started now. My name is Angie Rizzi, and I work at NASA Langley Research Center on the Science Directorate Education and Public Outreach team. We focus on Earth systems and work with the Globe Clouds team. I grew up all over the United States and went to 11 different schools before attending college. I received my BS in Industrial Management and Industrial Engineering at Purdue University, and then I got my MBA at the College of William and Mary. My first career was in information systems consulting, and I taught a few classes as an adjunct faculty member at Thomas Nelson Community College. This made me interested in working with middle school students to help them develop critical thinking skills needed for science and data literacy. After having my family, two children, both Hokies now, I went into teaching. I'm certified to teach middle school math, science, and high school earth science. I taught at a small private school and had the pleasure of working with all the middle school students. I organized the school science fair for many years, and our students were always successful in the regional science fair. I also actively implemented GLOBE in my classroom and worked with ozone gardens for 3 years. My students participated in the GLOBE International Virtual Science Symposium for a couple years, which provided a much more authentic experience for them. Being able to follow my students for 3 years allowed me to see the growth they achieved from their authentic participation in science. And that's why I can confidently say that using GLOBE with them produced results. Today, I'd like to introduce you to some new and revised NASA Cloud resources. These resources were developed to facilitate engagement with the science of clouds in a variety of environments, even if learners can't safely make their own observations. I'll cover the Globe Family Cloud Guide, which can be used in the classroom as well and encourages family engagement. Then we'll discuss the Globe Clouds 2020 Summer Citizen Science Effort and lessons learned from that challenge. And lastly, I'll talk about the student project support page. I have put indicated times here where these topics start in the video so that you can go back and revisit those topics if you want, or skip to the topics. So what is Globe Clouds? GLOBE is an international citizen science program sponsored by NASA, and it focuses on Earth observations and is organized by Earth sphere. This summer, GLOBE celebrated its 25th anniversary. Participants make observations and measurements and can submit them to GLOBE. Scientific protocols have been established for each measurement. The most popular protocol is CLOUDS. Originally, observations were recorded on paper and entered via computer, but GLOBE has added an app called Globe Observer, and people can use the app to make and submit observations on mobile devices. When many students stopped attending school in person, We put together some resources for globe clouds to support engagement with clouds from home. This is called the Globe Clouds Family Guide, but it can certainly be used in a virtual instruction environment or a face-to-face environment as well. The web page for the guide has a short introductory video about making cloud observations. There's also a link to a NASA EO Kids issue that features Earth scientists, including Marile Colon Robles, who is the NASA Globe Cloud scientist. From this page, you can also find out information about how to record cloud observations, how to get a personalized email from NASA, the Family Cloud Challenge, and a collection of videos about the science of clouds. This video explains how to get started making and recording observations. So you can see that it's a great thing to get started and make the observations using the app, and it's a very easy thing to do. If you make an observation when there is a satellite overpass, you can get a NASA personalized email about your satellite match. The cloud observations sent using Globe Observer are compared or matched to NASA satellite data. The app can also alert you when a satellite will be in your area. If you send the observation either 15 minutes before or 15 minutes after a satellite overpass, you might get this email. So you can see from this particular email here that we match to the GEO satellite, which is the column in yellow. And most of the time in North America, you will be able to get a GEO satellite match. But sometimes for the polar orbiting satellites that don't come by as frequently, like Aqua or Terra, which you see Aqua in the blue column, you'll need to find those satellite overpass times. And you can find that in the Globe Observer app, and you can get alerts as to when those will be. And this match table will show you what the satellite reported and what the observer reported. And it also shows the pictures that you took. So this is a great thing to use with students for them to be able to see what kinds of differences there might be, help them refine their skills, but also help them think about things from the different perspective of the satellite versus the ground. And I used to use these as kind of a bell ringer type activity with my students for the observations that they had made previously. So the Family Cloud Challenge and the Science of Cloud videos, which you can find on the Globe Family Cloud page, are also things that we used in our Globe Cloud Summer 20 citizen science efforts. And the Summer Challenge was structured to promote engagement with clouds without requiring observations. Because in the summer, not everybody felt safe going outside, and not all local regulations even allowed it. Observers can make observations if it was safe, but they could participate without having to do that. So we had put together a lot of resources, and the challenge was quite successful. And because of that success, we repurposed some of them and put them on the Family Clouds page. And so instead of the Summer Cloud Challenge, it is called the Family Cloud Challenge, but it's really effectively the same thing. And the beauty of this challenge, if you can see from this, this is basically the choice chart of what they could do, is that it can be done in the classroom, it can be done at home, and families can engage with this too. So it doesn't have to just be the student doing it. And the activities are categorized as either engage, learn, create, or observe. So the idea for this choice chart is to have whatever the goal is of filling in a certain number of these clouds. You can make it fun, like, 50% cloud cover or 10% cloud cover or something like that. But it's got the options, and there are videos that they can watch, which are those Science of Cloud videos as well as activity videos. There are journaling activities, there are hands-on activities, and the web page has links for all of these different activities and videos. In addition, I'll give you a little bit more detail of what the Science of Clouds videos have. So all but one of them, there is a pair of videos. So we have the science topic, and then we have an activity that goes along with that. The only one that doesn't have a corresponding activity is the How to Read Your Satellite Matches video. So we have the videos on citizen science, um, the satellite matches, how the observations are used in research, clouds and weather, the climate, and aerosols. And going along with those, we've got a cloud cover estimation activity, cloud fun and journaling. Students can make a cloud in a jar. There's an opacity activity, and there's an aerosol catcher. And so these videos were very popular this summer and very well received. I know everyone's been doing a lot of virtual, and sitting in a presentation is not the most engaging form of learning. So I'd like to invite you to pause at this time and go visit the Family Cloud Resources page. That's the first URL on this slide. Take some time, explore, see what resources are of interest to you and which ones you think might be helpful. And once you've done that, please go visit the Padlet, which is the second link on this page, and there's the QRL code. You'll see out in the Padlet that we have all these columns as I showed before. And I'd like you to put some comments into the Family Cloud Guide, Family Cloud Challenge, and Science of Cloud videos columns about how you might use these resources. And if you have any questions, please feel free to put some questions in the Padlet or email me. So thank you for taking the time to look through the family and challenge resources. We learned some lessons in this 2020 challenge, and the theme of our challenge was actually Science is Better Together. And we learned that science is better together. We learned that there's quite a large demand for videos of how to do the hands-on activities, and so we made an effort to expand on those videos. The choice chart was very well received. And one fun thing that we found out was that in the Globe Observer app, you do have the option of taking the photos, including up and down. And some of the downward pictures were really neat because they had lots of different plants in them. So that was fun. This picture here on the right-hand side is also one of the creative things that people did where some people could do, where there was knitting or crocheting of the different sky colors. And so they would take the different colors of blue representing different sky colors and do a couple rows each day for whatever sky color they identified that day. Just putting that in there to emphasize the fact that there can be a creative aspect or element to this as well. So the next few slides, I just want to go through and show you. I just randomly chose one day during the cloud challenge and picked a few of the cloud photos that were submitted that I thought were kind of interesting. And I'm just going to run through those for a minute, just so you can get an idea of the different kinds of things that people might see when they make an observation. Great. So the pictures that people took and submitted are a great segue into the student project support page. We've collected some topics along with suggestions and some videos for ideas on what to do for a student project. And these are projects that students can do without having to collect their own data. The 5 topics for these projects are making a cloud observation, contrail identification, obscured versus overcast skies, air quality, and satellite matches. And I'm going to give you a little bit more information on each idea. The overall concept of this is that the students can obtain existing GLOBE data, primarily using the GLOBE visualization or GlobeViz tool, and they can find photos that have already been submitted. From those photos, they can make their own observations, ask questions about what was observed, look for patterns, find and log differences, tell a story, and even possibly make recommendations on how to improve observations. So in case you're not familiar with it, I'm going to quickly take us out to the Globe visualization tool, which looks like this, and show you how you would pull up cloud observations. So what you're going to want to do is go over here into the different layers. You're going to select atmosphere, go down to clouds, and select cloud cover, and then submit that. And now you see cloud observations. Up here, you can select different days. Okay. If you were to click on an observation, a window will come up. This one actually indicates that the cloud cover was obscured and the smoke is true, meaning that they observed smoke that day. This was on October 2nd of 2020, and if you click on the photos, you can see a photo here I believe I've seen this one before, and in the comments it said, yes, that is the sun. So that's how smoky it was, that it looked like it was night, and that was the sun. So this is how you can obtain the photos. I'm just pulling another one up here just for interest. And here you can see north, east, south, west, up, and down photos. Those are all the options. So this is how you can get in and you can find observations and find the photos. Just as a brief introduction, there are tutorials and things for that tool available, but I just wanted to let you know. So our first project idea then is cloud observations, and this is the simplest idea and probably for the youngest students. But the students can take those pictures that I just showed you, and they can even have a data collection form, and they can um, make their own observation from the pictures. What do they see in the sky? And they can record it on the sheet. I'll remind them that they should not submit that observation to Globe because in fact it's already been submitted, but they can practice their observation skills. And they can actually see if their observation agrees with what the observer said. They could ask questions about it. They could look for patterns. They might even try to correlate it with weather events or pursue any other ideas that they might have. But it's just a great way to get them engaged with data that have already been collected so that if they can't go outside and do that, they can still be practicing a science skill. The next one is the contrail observations. And the contrails are actually classified as you see on the bottom of the screen here, that there are short-lived contrails, those contrails that by the time the plane is gone, you really can't see the contrail anymore or the back of it. Those persistent contrails are the ones that stay for a long time in the sky, even when you can't see the plane anymore. And then persistent spreading, as the title suggests, those hang around a long time and they also spread in the sky. And so sometimes those are very easy to confuse with cirrus clouds. So it's a very interesting thing to sometimes perhaps look at those and see if the students think that it was in fact contrails or maybe was it cirrus clouds. And then for the short-lived, an observer might have observed and reported short-lived contrails, but by the time they take the picture, those may already be gone. And so that's a very interesting thing for them to look at. Now we have prepared a data file for this with selected data that students can use, and that is available on the page. The next thing is obscured versus overcast skies. So you can see here on the picture in the top left is actually a sky that is obscured by smoke. And on the top right is an overcast sky. So obscured is when something is blocking your view of the sky, and overcast is when the sky is completely or almost completely covered. And students can find observations that indicate obscured and overcast. The black dots in the globe visualization tool are obscured, and they can practice those same kinds of skills, making an observation, comparing it to what the observer reported, and they can also start to integrate other data, and they can lay a base map on in the globe visualization tool, which I'll show on the next screen. They can use things like NASA Worldview and Aerosol Watch, other sources, to see if they can find evidence of things like dust or volcanic ash or haze or smoke. And we also have a sample data file for this as well. The next idea we have is for doing an air quality investigation. And so we all know that there were a lot of wildfires out west this summer, And if you see all these black dots from the globe visualization tool, which indicate obscured skies, and as we saw when I pulled a picture up, if it says cloud cover is obscured and smoke is true, then that means that smoke was reported. These pictures show that there might have been something in the sky, and certainly it could be smoke. And in the globe visualization tool, I turned on the base map for the aerosol optical depth, and you're able to see from the satellite imagery here that in fact there was something there, and so it's indicative of the idea that there might have been a lot of smoke and perhaps there was a fire, and they can look in worldview and they can perhaps even find an image of the fire as well. We have a data file for this one as well in case it's hard for them to find the data. The last idea is to find observations that have a satellite match and have the students take a deep dive into the similarities and differences between the observer data and the satellite data. When they pull up a photo, they can simply click next to the satellite matching where it says open in a new window, and it will open up the satellite match table for them. They can look at what the satellite reported compared to what they had the observer reporting, and they can see if they think there's a logical explanation for why there might be a difference. They can see if they agree. If there are differences, it could be because clouds at one level are blocking a view of clouds at another level. And also the globe observations are based on categories of a percent cloud cover, like between 25 and 50%, or that type of thing, where the satellites report a much more precise cloud cover percentage. So there are likely to be differences there. Like contrails, obscured versus overcast, and air quality, we also have prepared a sample data file for this so that students can get started and it's not too difficult for them to obtain some data. At this time, I'll ask you to pause the video again. Please go and visit the student project support page. And once you've had time to explore that, go back to the Padlet and tell us what you think you might be able to use from that page, or enter any questions that you may have. And I'll be back here at the end with some contact information and final thoughts. Thank you for joining the presentation today. I really appreciate your time. I hope that you found some interesting and useful resources. I will be happy to answer any questions that you might have. Please feel free to reach out to me at angela.rizzi@nasa.gov. Also, you can continue to add thoughts and questions to the Padlet. I'll check that periodically and get back with you. If you want a more timely response, I would suggest email though. And I hope that you enjoy the rest of the VAST conference. Thank you.